The equation of time. The reason that the Sun is not always overhead correctly on time is due to the tilt of the Earth and the elliptical orbit. This can be plotted as a graph, known as the equation of time. The greatest difference in time is found in February and November. The apparent day. The apparent solar day varies in duration. It starts when the Sun transits an observer's anti-meridian. Since the speed of the Earth along its elliptical path varies during the year, the apparent length of a day also varies. In addition, as the Earth rotates on its axis in an anti-clockwise direction and revolves around the Sun in an anti-clockwise direction also, the Sun will appear to have moved in space. The Earth therefore must rotate for more than 360 degrees to produce two successive transits. The sidereal day. With a datum located at an infinite distance from the Earth, there is little relative motion between the Earth and the datum, the rotation of the Earth being almost constant. Successive transits of the datum take 23 hours, 56 minutes, 4.091 seconds. Hour angle. Greenwich hour angle is the angle measured when travelling westwards from the Greenwich celestial meridian to the meridian of the body in question. Hour angle of an object is the angular distance measured westward along the celestial equator from the observer's meridian. It represents the right ascension, longitude, for a particular location and time of day. The difference from longitude is the hour angle measured westwards from 0 degrees to 360 degrees. Longitude has Greenwich as a reference. Hour angles may be referenced to three different points: sidereal hour angle, Greenwich hour angle, and local hour angle. The local hour angle is the angle formed when moving westward from the observer's local celestial meridian to the datum meridian. Right ascension. Right ascension is the celestial equivalent of terrestrial longitude. Both right ascension and longitude measure an angle from a primary direction, a 0 point on the equator. The mean day. A mean day is an artificial unit of constant time, based on the average of all the apparent solar days over a year. The mean Sun is assumed to travel round the Earth in a circular path, in the same plane as the equator, at a constant speed. It therefore crosses meridians with exactly 24-hour intervals of time. Since the Sun completes a 360-degree circuit of the Earth in 24 hours, the apparent rotational speed of the Sun can be expressed in arc of longitude as 15 degrees per hour. Time references. Time is expressed in four main systems: local mean time, universal coordinated time, UCT or UTC, universal time, or local standard time. The arc to time relationship. 15 degrees of longitude equals 1 hour of time. Arc to time example. Calculate the time taken for the Sun to travel from Greenwich, east-west 000, to west 060. Draw a circle showing the plane of the Earth at the equator. Add west on the left and east on the right. Locate east-west 000 and west 060. Calculate change in longitude. It's 60 degrees. The Sun travels at a mean velocity of 15 degrees of longitude per hour. From east-west 000 to west 060, the change in longitude is 60 degrees. 60 divided by 15 is 4 hours. The Air Almanac, arc to time. In the Air Almanac, there's a conversion of arc to time table. It shows degrees of longitude from 0 to 359 and then starts again, and also minutes of longitude from 0 minutes to 59 minutes, with corresponding hours and minutes or minutes and seconds of time. LMT to UT conversion. LMT to UT differs by wee. In other words, LMT add westerly longitude or subtract of easterly longitude to get universal time, or vice versa. Flight time. When doing calculations, it's advisable to convert to UTC and do any flight time calculations in UTC. Time zones. The Zulu time zone is based upon the prime meridian 000 east-west and covers a band of longitude of 15 degrees. Standard time. In the Air Almanac, there are standard time lists 1, 2 and 3. List 1 shows places fast on UTC, which are mainly east of Greenwich. The times given should be added to UTC to give standard time, or subtracted from standard time to give UTC. At the bottom of list 1, there are corrections for summertime, which should be noted. List 2 shows places normally keeping UTC, such as Iceland, Ireland, and Great Britain itself. List 3 shows places slow on UTC, generally west of Greenwich. Times given should be subtracted from UTC to give standard time, or added to standard time to give UTC. Once again, at the bottom of the list are corrections for summertime. The international date line is at the back of the world, close to the 180 degrees east-west meridian. Countries are aligned with it to keep their time zones consistent with other countries and geopolitical areas. The sunrise-sunset circle. In the almanac, there are 4 times: sunrise, sunset, end of evening civil twilight, and start of morning civil twilight. The Air Almanac has explanation pages which describe its use. Sunrise-sunset symbols. An open box depicts that the sun remains continuously above the horizon. Closed-in, filled-in box depicts that the sun remains continuously below the horizon. If there's slashes, the twilight lasts all night, i.e. the sun is at less than 60 degrees below the horizon at midnight. Continuous night, filled-in boxes may be seen at latitudes 68 degrees and above in the December and January period in the almanac. Continuous daylight may be seen in May and June and July, again at similar latitudes. The actual latitude where the sun at some time of the year will not be seen is greater than 66 degrees 33 minutes, north or south. Air Almanac times. The times of sunset and sunrise and civil twilight in the Air Almanac are given in universal time for the Greenwich meridian. If the event is not at Greenwich, then the universal time will differ by the longitude. For example, if we're waiting for sunset at 030 west, it will be 2 hours later on the UTC clock. Air Almanac example. So if it is 00:49:46 at the Greenwich meridian, the time at Plymouth, which is approximately 4 degrees west, will be about 16 minutes later. Sunrise, sunset, morning civil twilight, and evening civil twilight may be derived from the almanac. Civil twilight occurs when the sun is 6 degrees below the horizon,